All right, now here in this video, we're going to look at the constant multiple rule. And it states that if we have a function f is differentiable function and c is a real number, okay, so in other words, differentiable here simply means that we're able to take the derivative of the function, which means it's not undefined, and c is representing any constant real number, then if you take the constant and multiply it by the function, c times f, that's also going to be differentiable. So for example, what this means is if we take the derivative of our constant multiplied by a function, then that's going to be equal to the derivative of the function simply multiplied by the constant. Now, this is really wordy for something that's very, very simple. For example, that simply means if we have y equals 4 times x to the 9. Now, the long way to kind of overcomplicate this, to look at this, would be saying that, well, we want to take the derivative. Well, that means that y prime, 4 is our constant. So we could leave the 4 here as our constant. And if we take the derivative of x to the 9th, well, we know the derivative of x to the 9th. We pull the 9 out front. So we have 9 times x. 9 minus 1 is 8. So we have 9x to the 8th. And then we would simply then multiply. 4 times 9 is 36, x to the 8th. And there's our derivative. Now, really, the easiest part here, what this is indicating that if you know the derivative of your function, and then you to multiply it by a constant, that's going to be the derivative of the constant times your function. So in other words, if you're just multiplying by this constant 4, you can simply take the derivative of x to the 9th, which we know is 9x to the 8th, and then multiply that by the 4, and that would be your derivative. Now, technically what that really means is if we have y equals 4x to the 9th, we can really simplify this by simply saying we're going to multiply the 9 out front, but now we're just going to multiply it straight to the 4. So 9 times 4 is going to be 36 x to the 8th. So that is all that this constant multiple rule up here is indicating when we say c times f prime of x. So with this kind of the power rule, we're just going to take the 9 and simply multiply that out front. So if we look at the example of y equals 5 over 2x cubed, again, we want to rewrite this problem so that it's in a form that we're able to take the derivative. Now, if you notice when I say that we're going to rewrite this, I'm going to write y equals. Notice I'm not going to put the y prime here because we're not taking the derivative yet. We're simply rewriting the problem. So I'm going to rewrite this as 5 halves. So there's our 5 halves. And the x cubed, now there's two ways you could do this. If I do this step by step, we could actually say, well, we want to move the x cubed to the top, and that would be x to the negative 3, and the 2 is going to remain on the bottom. And you can work with it this way. Or what I prefer is we could actually think of this is the same thing if we were to write this as 5 halves x to the negative 3. I just think if you're taking the derivative, this maybe looks a little bit nicer. And again, all we're doing here is pulling the 5 halves out. It's kind of like if you have the problem here, if you had, let's say, x times 1/2, you could go ahead and multiply the x, and that would give you x over 2. So that's the same thing we're doing here with the 5 halves. We're just pulling the 5 halves out front. So now this is all set up, and we can easily take the derivative. Negative 3 times 5 halves, we would have a negative 15 halves x. Now remember, we're subtracting 1, so the negative 3 becomes, and this is where you got to be careful with the negative sign, so it's not going to be a negative 2, we're subtracting, so minus 1 is going to be a negative 4. And I guarantee you, if you're not careful here with the subtraction, when you have a negative, it's easy to make a mistake. So there's the derivative, and at this point you can leave it in this form. Again, it's not too big of a deal to leave your exponent as a negative. Or we can simplify by simply moving the x to the negative fourth to the bottom, and you would have negative 15 over 2x to the positive 4. Okay, moving to our next example. Now, if you notice, this looks very similar to the example we had above, but notice now it's 5 over 2x, and the whole 2x is in parentheses is cubed, whereas up here we had 5 over 2x cubed and only the 3 is cubed, so therefore we only move the 3 to the numerator. So once again, before we can actually take the derivative, we want to rewrite the problem. And to do that, I'm actually going to go ahead and cube the denominator, and I think that's going to make things easier. So we would end up with 2 cubed, so that's 8, and then x cubed. So now this looks very similar to the example above, and we could still rewrite this. Again, we could have the 5/8 out front, move the x cubed to the top, so that becomes x to the negative 3, and now we can easily, once again, use the power rule. And what does that tell us? Well, that says we can take the negative 3, multiply that by the 5/8, so that's a negative 15 over 8. We're going to subtract 1 from the exponent, so negative 3 minus 1, we end up with negative 4. And then, of course, we can simplify. So we have the negative 15 on top. The 8's already in the bottom. Move the x down, so we have x to the positive 4th. All right, and one last example here. Y equals 7 over 3x to the negative 2. We notice here that we already have a negative in the exponent, or x to the negative 2 is in the denominator, and it's already negative. So that means if we go to rewrite this problem, we still want to move the variable to the top, but now we're going to have 7/3. And if we move it to the top, or here out front, if we move the x up, because the exponent's negative, now it's going to become positive. So now we can simply use the power rule and multiply the exponent. 2 times 7/3 is 14/3. Subtracting 1 from the exponent, we simply have 14/3 x. And keep in mind, you could see it written this way. You could have 14x over 3. Either one of those would be correct. All right, so to quickly review again, if we're looking at what's called the constant multiple rule, that just simply means that if your function is being multiplied by a constant, then you can simply take the derivative of your function and then you're going to multiply by the constant.